Good morning, good afternoon, good evening, everyone. Welcome to this Nmrg session for the IETF 111 meeting. I hope you can hear me well and also see the slide that I'm sharing. If this is not the case, please send something in the chat. So Jérôme and myself, we chair the session today. And we have a few introduction slides to give a few guidelines for our meeting. So concerning the Notewell, a few announcements. So audio and video recordings, if you participate online and turn on your camera and or microphone, then you consent to appear in such recordings. So please be aware that this meeting is being recorded as we started, and that you agree with such a policy right now. Privacy and code of conduct. So as a participant in or attendee to any IETF activity, you acknowledge that written, audio and video and photographic records of meetings may be made public. Personal information that you provide to IETF will be handled in accordance with the privacy policy that is available at the link that you can see in the slide. As a participant or attendee, you agree to work respectfully with other participants, and please contact the Ombuds team if you have questions or concerns about this. And you can find additional information in the two RFC that you can see at the bottom of the slides concerning the code of conduct and anti-harassment procedures. Now, a few words about goals of the IETF. So the IETF, Internet Research Task Force, conducts research. It is not a standards development organization. And the IETF focuses on longer-term research issues related to the internet, while the parallel organization, the IETF, focuses on shorter-term issues of engineering and standards making. While the IETF can publish informational or experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, applications, architecture, and technologies. And if you want to have more information about the goals of IETF and the various research groups, you can look into RFC 7418. Online meeting etiquette. So as mentioned already previously, the session is being recorded. Please keep your audio muted and video off when you are not presenting or speaking. And when speaking, please start by stating your name and affiliation. This is very useful for people that will look at the recordings after. You can also get some useful links in the agenda that is available on the data tracker. So the materials for these sessions, we have a shared note with CodeMD that is available. We will have also recordings of the session that will be available after the session on the YouTube channel, IETF YouTube channel. For the agenda today, so this is the current introduction, first point of the agenda. Then we have let's say, technical topic around digital twins with 3 presentations. We will follow that with a dedicated presentation on building context-aware data aggregation framework for network monitoring. Jérôme will follow with a status on the research challenges for AI in network management document. Then we have a point on the activity related to intent-based networking with a presentation on the network measurement intent and status of the 2 research group documents related to intent-based networking. We have a few slides at the end, if time allows, to give you a quick update on the research group status. And at the very end of the meeting, if we still have our buffer time, we will also make a quick highlight of new contributions to the research group, where we would like to investigate further this work in a dedicated interim, but we would like to give opportunity to the authors to present quickly a glimpse of what they are proposing still in this meeting. So if you agree with the agenda, we will proceed with the first topic on digital twins. Let me switch to the other slide set now.
Hello?
Yes, I can hear you. Give me just a second to share the slide. Okay, I think this is the correct one.
Okay, I can see the screen. So can I start now?
Yes, the floor is yours.
Okay, hello, chairs and everyone. This is Chen Zhou from China Mobile. Today, I will present the draft update on behalf of our co-authors. Next slide, please. Actually, this is the first time to present the draft in this research group. And as we presented previously since IETF 108, the basic idea of the draft is to define digital twin network in network and communication field. Our goals of the draft is to define a new tool for efficient and intelligent management and to stimulate innovation with optimized cycles. The major technical contributions, including sketch reference architecture for digital twin network to identify key values and the challenges of digital twin network, and to provide typical application scenarios. Since IETF 110 we resolved open issues raised in Section 9 and reported back to the mailing list, then presented the updates on interim meeting on May 17th. And then we collected more inputs and comments from mailing list, and thanks to Ramin, Cedra, Pedro Martinez, Julia, and other experts. Next, four slides show the major updates we made in 04 version. So next slide, please. Okay, this slide shows the updates on core elements of digital twin network. Orchestration is removed from the core elements. Now the four core elements are data, models, mapping, and interfaces. We believe that orchestration can be consolidated into control function building block in digital twin network and also can be part of the functionalities in the reference architecture of digital twin entity management. Next slide, please. This slide shows the update on definitions on data and models. Uh, Data and models are usually the two common but separated elements for digital twins in most industrial fields. And as shown in the text, we added a more detailed description to clarify the definition of data and model in this version. Next slide, please. This slide shows the clarification on mapping definition and the updates of continuous verification. And mapping is used to identify the digital twin and the underlying entities and establish a real-time interactive relation between the physical network and the twin network or between twin networks. The mapping can be one-to-one vertical mapping or one-to-many horizontal mapping. And continuous verification is an extension of DevOps practices that are concerned with verifying the system as a whole. Closed loop control and stimulation enclosed in digital twin network supports dynamic mechanism required by DevOps procedures. So next slide, please. This slide shows the reference architecture of digital twin network. It is of a three-layer system. The lowest layer is physical network. The intermediate layer is network digital twin. This layer includes three key subsystems, data repository, service mapping models, and digital twin entity management. And top layer is the network application layer. And both conventional and innovative applications can run against DTN platform with low cost and less service impact on real network. Actually, this reference architecture was first provided on version 02. After made some updates on the architecture, we decided to change the draft title from concept of digital twin network to digital twin network concept and reference architecture. Next slide, please. Okay, the coming two slides show the detailed review comments from expert Ramin Sedra and our initial reply. The first comment is about reference on digital twin technology. The second comment suggested us to cite more papers on definition of digital twin to network. And the third comment is about stress us to clarify the benefit of privacy and regulatory compliance. The fourth comment is about function models. How can new function models be deployed in digital twin network? Next slide, please. The fifth comment is about data models, and this sixth comment is about resource consumption of DTN, monitor of performance and resource consumption, and also about unified interfaces. And the seventh comment is about the world record. And beside about 7 comments, there are also 14 other comments that are of grammatical errors, typos, and suggestions on better wording. And for all the comments, we have provided initial reply on each comment, either with explanation or accepted to revise in next version. So thanks again to Ramin Sedra for the careful review and the valuable comments. Next slide, please. And this slide shows another comment from expert Pedro Martinez Julia about the mapping of the reference architecture to other typical network management architectures. We believe our work is an expansion of network simulation and the unique difference from traditional network management architecture is using interactive virtual real mapping to build closed-loop network automation. Our concern is providing survey on other architectures might lose focus of this draft. So we decided to just add text in abstract and introduction in next version to clarify the scope and the relation with traditional network management architectures. Next slide, please. This slide shows that the concept of digital twin network is getting more attention from industry. Just last Tuesday on July 20th, digital twin network online session was held on a IEEE DTPI conference. The session built a platform for exchanging ideas on research and application of digital twin technology in network and the communication field. Our co-author, Diego Lopez, co-chaired the session. In this session, totally 7 presentations were provided. Follow them are about basic technologies of digital twin network, including traffic modeling, security applications, model of wireless channels, etc. And one is about architectural concept of DTN, which is very close to our draft and providing a method for DTN constructing. And another one is about data-driven routing based on DTN. Actually, the corresponding paper referred our draft in background in its background section. So based on this info, we believe that we are on the right way to continue our work on this draft in this research group. So next slide, please. Going forward, we will keep investigating more use cases and requirements of DTN and address any issues raised in this meeting. And after that, after address all comments and issues, we will request the research group adoption call for this document. Welcome to join our work, and any comments are welcome. Thank you.
Thank you, Sheng, for the presentation. Do we have questions or comments? Okay, I have a quick remark. I think it was when you presented the layered view. I think in the previous statement, you mentioned that there could be different way of having relationship between the real network, I mean the real infrastructure and the digital twin. But it seems like in this layered view that we need to go always through the digital twin to have actions or effects on the physical network. But is it possible to think about a different way to represent, especially the application layer and the physical network, that it can go in a direct interaction, and that the digital twin will sit aside of the physical network and will be, used in parallel to the physical network and not in between?
Okay. It's a good suggestion. Currently, it's true that currently we only focus to represent the physical network and the services running on the physical network in natural digital twin layer. And your suggestion to represent the applications on digital twin network it's not well considered, but basically I think it's not. We can think that applications running on the physical network is part of the object to be represented. So we will consider it later and to see whether we can add the description or add the scope or to represent as together with physical network.
Okay, thank you. So I've not seen other comments or raised hand in the queue. So thank you, Sheng, again for the presentation. We'll continue with the next presentation, still in the digital twin topic. Let me switch to the other deck. And Diego will be our presenter.
Yeah, it's me. Yes, I guess that's Miteko saying that you can hear me now. So I assume that's the case.
Yeah, we can hear you.
Yeah. Well, basically, before I start, just a comment of what your previous question, Luan, since I'm somehow involved as well in the DTA effort. Precisely what I believe is that this is the model when you are trying to control the network through the digital twin, but you can have other mechanisms for control, and then you can choose. It's not that every application that you want to use to control the network is going to be has to use the digital twin as intermediary. But in the case of the applications that are aware of the digital twin, for sure, that's a little bit like when you have an SDN controller, if you like. Okay, so apart from that, well, going to the task that I have tonight is precisely is about introducing some results that we have achieved in the 5 Growth projects, and in particular regarding the application of AI and machine learning for network management in industrial environments, and some conclusions that are related and that we believe are interesting to derive some general conclusions for the applicability of AI and ML in networking in general. So can you move on to the next slide, please? So just a very quick introduction to what the 5 Growth project is. It's a European project funded by the European Commission as a joint research project among several European companies, very much focused precisely on demonstrating how 5G technologies can be applied to improve the results of the in vertical industries in real production environments, and to explore the idea of combining management both by the network providers and the vertical industries, seeing achieving a common goal that is, as I said, are related to real life environments. Can you move on? And for this, to the next one. And for this in particular, the project is very much focused on pilots that are are running on real environments, in factories, in harbors, in railways, on which and the idea is to demonstrate how these deployments can be made in the industrial environment in cooperation with a public network service that is provided or is emulated by testing sites that are connected as well as to the pilot environment to demonstrate it. In particular, there are 4 pilots, 2 of them in Portugal on transportation, on railway management, and on energy distribution, and other 2, one in Turin in Italy, another one in between Bilbao and Madrid in Spain. Both of them focus on Industry 4.0. Can you move on, please? So apart from this, precisely to enable this and demonstrate the viability of these pilots and the use of the application of different technologies in network management and interaction between the application needs and a certain degree of control of the network to satisfy the application KPIs. The project has been working in several aspects that we innovating in the way in which the network functions are deployed, are managed, are security is provided, etc. In three main directions. One is on framework, as supporting, strengthening security and supporting, let's say, cloud native techniques to deploy and managing the different elements in the network. In aspects related to architecture and in aspects related to with concrete algorithms. This presentation is basically focused on the architecture, on how specifically on how the orchestration of the collection of monitoring data is applied, how this data is processed and combined and aggregated to provide the intended results, and how this combination of the orchestration and the data infrastructures facilitates the use of artificial intelligence mechanisms for control and management of the network environment. Can you move on, please? So, and for this, and this is probably the most important thing that is about this environment that has been demonstrated and in which we have been working for during the last couple of years, or more than a couple of years, is that the idea is that we have the project has gone in experimenting with what I have called here a 3-dimensional closed loop. It's not only the typical closed loop. You have the closed loop for control or for inference, in which what you have is an AI-based controller that takes decisions, taking into account the data that comes from the network, from the plant, and makes decisions that try to drive the network towards or according to a certain set of policies. Normally, there is a previous loop that is used precisely for training the AI mechanism using machine learning techniques, whatever the techniques you feel like. And the important thing is that there is a third aspect, a third loop here that is about precisely controlling the flow of monitoring data that is entering any of the other two loops. So you can control you can control how many data and of which nature and structure how enters the learning loop and enters the control loop. So you have a possibility of being much more adaptive and even changing AI models, changing training mechanisms, changing this without affecting the whole infrastructure, and changing, if you desire, the focus of the inference process or the particular activity or the particular data on which a learning process is based on. Can you move on, please? To demonstrate this, the idea is precisely, and this is what, apart from discussing this, what we want to show is that this has been demonstrated in an environment with a robotic digital twin, in which what you have is a robotic arm that is moving around in a factory, and that is connected using 5G network to an environment in which the digital twin application is running, and in which there are a couple of functions that are heavily dependent on aspects related to, specifically in this case, latency. So the mechanisms in which are used by the human controllers to interact with the twin has a particular request on latency, as well as the control that is enabled by the digital twin to be applied to the robot. Can you move on, please? The demo, I mean, or the demonstration that was run, the experiment was deployed between Torino at the Politecnico di Torino and Barcelona at the CTTC, and in which in the Torino was the environment in which the model were trained, and the AI model was trained and structured and uploaded to the control plant that was located in the labs of CTTC in Barcelona, in which the VNFs could be located either directly at the edge or in an environment that was reflecting a cloud data center, precisely to experiment with the idea of adjusting the requirements of the of the environment, whether in the cloud environment, whether in the edge, and adjusting the characteristics, and in particular the scaling mechanisms. I mean, of the scale of the solution running on the different infrastructure. Take into account that, again, is this three-dimensional loop allows us to train different modules using real data that are not necessarily the same model that is being executed, using a combination of data, and whenever there is change in the model, the collection of data for the inference loop can be changed as well. Can you move on, please? So basically, this is just to illustrate the different loops and the different flows. I'm not going into detail on this, but if you look at it, well, there is a phase in which, or is a separate phase in which you can make the model and training of the AI model. And once the service request happens, and the service request can include precisely the requirements in terms of the AI model to be applied, this is deployed, and the service model includes as well a configuration of the monitoring jobs and how data is going to be collected from the different elements in the network. Can you move on, please? And that implies, and this is important as well, that then the data flows are configured according to this. So you can, according to the model of the service, and according to the model of the AI and the machine learning environments, it's possible to configure the data flows to perform training and control inferences according to the requirements of that particular model in each one of the loops. Can you move on? And well, basically, the third slide just illustrates what happens when a particular scaling need is detected. And well, in this part, I would say is quite typical in the sense that is the application of AI to make a life cycle decision on a particular services. Again, what is important is that the monitoring jobs can be, once the decision is taken, and the monitoring jobs can be reconfigured to dynamically adapt the data flows. Can you move on? So just as a conclusion, and is basically that, well, the idea, let me say, is that we have been experimenting with this three-dimensional closed loop. We have for sure used the common double loop for learning and inference, I mean, for training the model and for applying the model. But there is important, the important addition here is that this additional control loop for the monitoring data flow, so how we can control the data, which data, and how it is combined to be fed into each one of the other loops, allowing a much higher flexibility of the whole system. This has been done precisely because one of the main goals of the project from the beginning was precisely to provide a complete data monitoring data infrastructure. So that implies that it's not only that we have the data infrastructure, that precisely, I guess it's Nacho, the one who's going to make another presentation of our data infrastructure. It's not only about this, but it's about including the requirements for data-driven operations in the service descriptors themselves, is supporting monitoring orchestration. I mean, deciding where data is collected and which data is collected from this point. And the idea that is about providing models about the data flows as well, that allow us to abstract the models, combine them, and make a much more powerful feeds of data to the AI and ML modules. And well, what is in practice is that we have applied and we have demonstrated it into an industrial use case, and taking into account that we are talking about a digital twin, an industrial digital twin, precisely we believe that this is some conclusions that could be interesting precisely in connection to what Cheng was presenting before, and in general to the application of a set of network services able to support in the future the use of digital twins in whatever the industry. Can you move on? Just the last one is just to show where more information can be found. There is a paper on this that, by the way, it was get some award to a best paper award, just to make a little bit of boasting, and this there is the demo. The detailed demo was presented in the Infocom, and you have, if you are interested, these two links. If you want to watch the demos with the digital twin, the robotic arm, etc., you have two versions, one shorter, one longer, if you are interested. And that's all. Thank you so much.
Thank you, Diego. There are two questions in the chat. I think we can overlook the first one. Do you want to take the question from Jerome? I don't know if you can see it.
Oh, yeah, I'm seeing it. In principle, the data flows can be adjusted based on user requirements as well. This is something that probably, well, Nacho will be talking about later on. So the idea is that since what you have is for data sources and data consumers, you can model them, and you have a general model of them. These include certain parameters that can be controlled precisely. I'm wondering whether you have any goals or degrees, reduce the lead time, or yeah, sure. That's precisely the idea. I mean, I'm trying to reply to Jong Geong Hong, if I pronounce it right. Yeah, the idea is precisely to optimize the time of response and to provide a much more agile response in terms of how you apply AI. It's not only about improving the AI response itself, which is important if you control the monitoring flows and you are able to identify what to feed and how to feed it to the model. But at the same time, it's precisely to improve the possibility of not being too rigid with respect to the model that you are going to apply. It's precisely this the diversity in how you monitor and feed data would allow you to, for example, to experiment with alternate models as you're applying one model and you are training another model using the same plan data at the same time. And this we believe this is quite important. And yes, Marie, you say, I guess the slides are available as with. Estimated the actual amount of NCP resources related to high fidelity. Well, this question is better, I would say, is better for Cheng because it has to do more with the previous one. The digital twin that we were working here with is the digital twin of a robotic arm. Pedro, not a general of the digital twin of a network. Probably this is something that in the general work in VTNs is something that should be considered indeed, and that's it's an interesting question. Yes, definitely.
Thank you, Diego. I think we can stop now the questions to be a bit
okay.
Stick with the timeline, and we switch to the next. Thanks, Diego, for the presentation.
Thank you.
Our next talk will be from Dan Young, an efficient data collection method for digital twin network. And here you go.
Hello.
Hello, Dan Young. I can hear you.
Okay. The topic of my presentation is an efficient data collection method for digital twin network, and the related draft can be found on the website. And next slide, please. The main contents of the draft are as the following 7 sections, and the introduction and overview will be the part will be the important part. And next slide, please. And in this slide, I will present the background and the introduction. The definition of digital twin network we refer to is from the first draft shown. The draft Joe Nmrg digital twin network concept, and the DTN is defined as a network system with physical network and twin network, which can be met in real time. So the construction of DTN requires real-time data of physical network to update the state.
I also have some audio issues. I don't know if you can hear me. Just to check if it's more on the
And
side
now
or the general. Seems to be back.
Okay. Hello. Can you hear?
Yeah, now it's okay. Please go on.
Oh, okay. The existing method collects the full amount of data from the physical network for modeling and doesn't consider the problems. So there are many disadvantages. First of all, is the huge storage space and the bandwidth resources are needed. And second, the computational efficiency is low. And the last is that there will be the waste of bandwidth resources caused by data transmission. Next slide, please. So the main process of this data collection method is to send instructions in the twin network to the physical network to collect data on demand. And then the physical network parses and executes instructions such as data cleaning or knowledge representation, and then sends the processed or represented data to the DTN. Next slide, please. The main models involved are shown in the figure. DTN consists of physical network and twin network, and we cite instruction management center and data storage center in the twin network, and set several data storage center in physical network. In the next few slides, I will introduce the main functions of each model. Next slide, please. So this slide is about the introduction of data storage center in physical network. It has two functions. Firstly, it can store data such as performance indicators, operational status, logs, traffic scheduling, business requirements, and so on. Secondly, it has the function of automatically parsing the instructions sent by the instruction management center in the twin network. So next slide, please. As the figure shows, the twin network includes the instruction center and the data storage center, and the instruction management has two functions. On the one hand, it's mainly used to manage the registration of the data storage center in the physical network. On the other hand, it's mainly used to adaptively configure the data collection instructions according to the collection requirements of the data storage center in the twin network, and search for IP addresses to send the instructions. So among this registration information would include various key information such as the IP address of the data storage center in the physical network, data type, and various index names of the data, and the data source name and the data size, and so on. Next slide, please. So the function of the data storage center in twin network is mainly to store the effective information after data processing and the knowledge representation returned by the data storage center in the physical network. Next slide, please. So the specific process is about first the data storage centers in physical network register to the instruction management center in the twin network, and the registration information includes the IP addresses of the data storage center, the data type, the data source, the data size, and so on. And then the data storage center in twin network sends the data collection request to the instruction management center. And then according to the data collection request, the instruction management center intelligently searches the registration information for addressing and configures the data processing instructions. Among this, the instruction carrying information includes rule-based mathematical expressions, executable models in .exe format, dynamic collecting frequency, parameterless program text fields in .m format, text fields with parameter configuration, and other types of fields. And these are created and modified. Next slide, please. And after that, the instruction management center in the twin network sends the corresponding instruction according to the address to the data storage center in physical network. After receiving the instructions, the data storage center in the physical network will parse and execute them according to the instructions, such as filling missing data association, knowledge representation, and so on. The data storage center of the physical network will send the processed and represented data to the data storage center in the twin network. And next slide, please. So the advantages are mainly about that. First is the need for storage resources in the twin network is reduced. And next, it reduces the need for computing resources and improves the efficiency of data processing and representation. And then the bandwidth resource consumed by data transmission is greatly reduced. And next slide, please. So in the next, we will analyze the instruction carrying information more detail and discover more concrete examples of data collection and consider about the extraction. Consider about the extension and thanks and looking forward to the comments, suggestions, and questions.
Danyang, I think you are finished with the talk. Do we have questions for Danyang on the presentation? I have a quick comment. Jérôme, yes, I see on the chat. Jérôme, raising hand.
Jérôme François speaking. Thank you for the presentation. For me, there is something that remains unclear because one of the main motivations is to reduce storage capacity of the digital twin. But somehow it gives me the impression that that with your approach only moves the problem towards the physical network, and also put more, let's say, pressure on the physical network where you have to do a lot of processing. And that can also have some disadvantage, as maybe the physical networks are sensible and sensitive and should not be maybe overloaded with too much additional processes. Have you considered this issue? What's your opinion of that?
Okay, thank you for your suggestions, and your problem is very good. We will consider more more clearly and in the next. Hello. My network is worse, and if you
Danyang,
if it's happening for you, please please send an email to me. Thank you.
yes, I think that's the good approach. If you can take the discussion offline, and I heard that Danyang is willing to consider the suggestions in future work. So thank you, Danyang. Thank you, Jérôme, for the point.
Thank you.
Oh, okay. Thank you for the chair.
I don't think we have other questions. Okay, thanks. Yeah, so moving on to the next presentation, which will be, I think it will be Diego again, building a context-aware data aggregation framework for network monitoring. Let me check, where is this one? So I think it will be Ignacio.
Can you hear me? Yeah.
I can hear you, yeah.
Okay.
Just
I will be
checking.
presenting, yeah.
I think it's this one. It's correct?
Yeah. Yes,
Okay.
thank you. All right. Okay. Well, hi, everyone. My name is Nacho. I'm a PhD student at the European University in Madrid, Spain. And in this presentation, I will give you an update on the semantic framework that my colleague, Danny, Diego, and myself have been working on within the Five Growth project. So next slide, please. Here is the index. I'll first introduce some basic concepts, then I will go through some examples for context modeling. Then I'll show you the internals of this framework, and then a real use case, and to wrap up some conclusions. Next slide, please. Next slide, please. Okay. So when it comes to network monitoring, the network operators have to deal with a huge amount of data sources, each with different nature, which entails multiple domains, such as the access part of the network, the core, also multiple technologies, such as containers, legacy systems, multiple vendors. So to this end, the network monitoring have to cope with different transport protocols, different encoding formats, subscription mechanisms, either pull or push. So what we want to propose is to capture the metadata that characterizes these data sources, and we want to make this possible by leveraging the HCSIM standard for context information management, with the ultimate purpose of building a semantic framework for network monitoring that will first apply modern streaming telemetry techniques that I'll show you later on. Also enable the configuration and description of data pipelines by means of context. And of course, transformation between the data model of the data source to the data model of the data consumer. Next slide, please. So the HCSIM standard focuses on defining mechanisms to exchange context information in interoperable way. To this end, HCSIM standardizes the so-called NGSILD protocol to exchange context information. And this protocol is composed of two main ideas. First is the NGSILD information models, which are based on property graphs to represent that context information as, let's say, a network of entities, properties, and relationships. And the second idea is the definition of the so-called NGSILD API, which essentially is a REST-based API for managing the context. Next slide, please. So when exchanging context information, these are the components that are identified. At the core, there's the context broker, which stores the context information. Then we have the context sources, which produce context information, such as Yang-based devices, and then context consumers, which query and subscribe to context information from the context broker. Next slide, please. So let's see some examples of modeling data sources. Here's the first one, which is Prometheus-based data source, where in this diagram, you can see the information model for this data source, where we have an entity representing the Prometheus server, which can be accessed through a specific endpoint with some credentials. And also, this Prometheus service has some metrics with a particular name and a set of labels. And in turn, these metrics belong to a certain metric family. Just to clarify that we are aligned with the Open Metrics initiative, which defines this schema for metric and metric family entities. Next slide, please. And as a second example, telemetry-based data source. Here in this diagram, we've defined the entity device, which represents the telemetry service. In this example, we chose GNMI. As you can see, it captures the version of the protocol, the supported encodings. Also, it has an endpoint associated with some credentials to access it. And on the other hand, this telemetry service supports some Yang modules with the associated metadata, such as the name, the revision, and the organization. Next slide, please. So let's see the semantic aggregator framework. Next slide, please. This is how the architecture looks like. At the bottom, we see the data fabric, which manages the monitoring data. We selected a set of big data tools, such as Apache NiFi, to collect the data from the data sources and to deliver it to data consumers. In the middle, you can see Apache Flink for data aggregation. And all this is possible thanks to Apache Kafka. So these big data tools can publish and subscribe to the monitoring data. And at the top, it's what we can call the context plane, where the context information is stored in the Scorpio building block, which is an implementation of the context broker. On the left-hand side, the data sources will produce context information, such as the Yang modules supported by a device. And on the right-hand side, the data consumers will query and subscribe to this information, so they can later on define the data pipelines that provide this information. And in the middle, there's the building block that we developed, which is called Weaver, which is basically the brains of the aggregator. And this block is responsible for stitching the context plane and the data fabric. So it will essentially consume context information and translate it into certain configurations in Apache NiFi and Flink. Okay, next slide, please. So here, this is an example, a snapshot of a data pipeline. This is just to give you an idea of a specific task run by Apache NiFi that collects a certain metric from Prometheus and stores it in a given Kafka topic within the semantic data aggregator. So the idea is that the data consumers would discover this metric that you see at the left, and they will request to schedule a task that runs on NiFi template to collect this data and store it in Kafka. Note that this is the first stage of the data pipeline. Let's say the collection, the ingestion of data, and this will continue if we had more space with another task for aggregation and another task for the delivery of data. Next slide, please. So let's get more practical and see a real use case. Next slide, please. So the anomaly detector is a module that our colleagues of the 5 Growth projects have developed. This module is responsible for analyzing measurements of rank KPIs. And based on this analysis of data traffic patterns and mobility patterns, the anomaly detector can identify and predict anomalies in a run cell. This module exposes a REST API for ingesting streams of events, and it also provides a notification alert system to send these derived predictions. Okay, and here at the bottom you can see the data model that it requires with some KPIs. Okay, so next slide. So how can the semantic data aggregator help here? First, by means of context, the semantic data aggregator provides a mapping, let's say a mapping of which data source provides which rank KPIs. For example, think about a certain KPI is provided by Prometheus, and another KPI is provided by a legacy system. And then by consuming this context information, the SDA is able to collect all these measurements required by the anomaly detector, aggregate them per cell ID and during a given time window. So the idea is that this aggregated data is combined and transformed into the data model that I showed previously. And this is delivered through a REST API. Next slide, please. To summarize some conclusions, next slide, please. Data-driven network management, as we saw, requires the integration of a wide variety of data sources and data consumers. We proposed a context-aware management based on the SIEM standard by modeling the data sources, consumers, and pipelines. And we developed a monitoring framework for collecting the data and aggregating it. And this is possible by separating the context and data planes. Next slide, please. And potential next steps that we identified. First, the combination of context information from different levels, such as what we call the operations level, which could be a network function and network service. Think about the telemetry-based data source that I presented. Well, that device entity could be linked to a network function entity, which in turn could be associated to a network service entity, and also combination from the business level, such as network policies, intents, SLAs, owners of domains, etc. Also, we started working with the authors of the same draft to make this framework aligned with the same architecture, because the aggregator could fulfill the role of design agent. The assurance graph could be captured as more context information. And also the semantic data aggregator could collect, as we saw, monitoring data from different data sources of different nature. Also, auto discovery of context information, such as when a new network, when a new element appears in the network, the aggregator has to be synchronized with that information, with that context information. Also, the implementation of an northbound API for interacting with the semantic data aggregator, because so far the consumers or the experimenters have to define those data pipelines by leveraging the NGSILD API. Our idea is to introduce an abstraction layer on top of it. So the experimenter would just say, okay, I want this metric from Prometheus, compute the average during the last minute and send it to MySQL. And last but not least, closing the loop. If you remember the real use case with the anomaly detector, we show the path of collecting monitoring data and feeding it to an AI engine. Because the anomaly detector is basically an AI engine, so we could see the picture the other way around, and in that case, the aggregator could collect those predictions produced by the anomaly detector and transform them into configuration data to be applied into the network. Okay, next slide. So that's all for this presentation. Thank you for watching. Any questions?
Thanks, Ignacio. Questions from the floor? Check the chat. I don't think we have questions in the chat. Question comes to my mind because you mentioned that you want to use semantic information. And I'm not sure I get it from the presentation, but are you maintaining a kind of ontology of the different concepts? And I mean, I don't really care if it's an ontology or not, but who is, developing it, maintaining it, and how it gets updated? Because usually if you want to talk semantic, you need to have some common definitions. And in fact, who is, feeding those definitions? If you have, let's say, new technologies, new context, or if there are some specificities from different vendors, different operators. I don't know if you have explored this, how it is done either in the project or in the ISG SIM.
Well, we are aware of that, but we haven't got into it yet. Because an ontology would be ideal, but so far our way to work is when we integrate a new data source such as Prometheus, we try to capture all the context information associated to this data source. And for example, in the case of Prometheus, we found the OpenMetrics initiative. So that could be a sort of ontology for us in that case. In the example of telemetry-based devices, there's we assume that these devices support YAML modules. So that covers it all with the supported YAML modules. But yeah, that's all for now.
Okay, thank you.
Sure, thank you.
Okay, so thanks, Ignacio, for the presentation. Looks very interesting, and it's nice that you are also connecting to other works like the drive on SANE with the other colleagues. So let's see if I'd like to see these future works in the next meeting. Thank you.
Sure, thank you. Bye.
Thank you. Bye bye. Our next presentation will be from Jérôme, if I'm correct, to give a status about the research challenges document.
Yes, okay. Thank you, Laurent. And hello, everyone. So yes, I will give an update on the document. So, next slide, please, Laurent. So maybe just first, maybe to summarize what happened in the last month, in particularly in June. We had a dedicated meeting, a virtual meeting, to this document with the following objectives. The first one was to freeze the challenge list in order to progress on a particular set of challenges. It does not mean that our objective was to say that we are 100% convinced that we do not need to extend the list or to modify the list, but at least to freeze the list till we reach a good, let's say, a good document for this particular challenge in terms of content, but also in terms of format and editorial style. So then the second objective of the meeting was to define also the template to be used and also to have one lead contributor per challenge. And also, yes, to define some realistic milestone regarding the how to progress in the document. So you may have seen this this report on the mailing list, but just to summarize here to all the participants of this meeting. It's important to know that there is a new, let's say, version 3 of the document that is a version where we integrate the different comments received so far and where we adjust actually the list of challenges. So do not edit, but also do not read the version 2 anymore. It's not up to date. Please use the last link provided below. Anyway, if you go to the version 2 of the document, you should have the same disclaimers that will redirect you to version 3. Next slide, please. So I will maybe start to summarize what is the template that we agree to follow for each description that you have in the document. So the idea is to have the same organization in terms of structure, but also to have the same level of details. In particular, it's important to have the same organization because maybe at some point we decide to merge a challenge, it will be easier if we clearly see what are the different parts. So mostly there are 3 parts that are quite common. The first part is about the motivation of the challenge that should highlight the criticality or the impact of the problems that need to be addressed, of course related to the coupling between AI and network management. We should have also sections that summarize what is the current state of the art related to the challenge, at least to see what are the trends and basically somehow how to identify the gap between what has been proposed and what remains to do to fulfill the challenge. And also per section that will be more descriptive regarding the challenge. And most of the time we have seen that the challenge, you have a main challenge that you want to reach, but you have multiple problems or multiple sub-challenge you want to solve, to address it. And so, yes, as I said before, it's important to make the comparison with the state of the art. And if there exists, because it's not always the case, it's possible to include some existing proposition for maybe not completely addressing the challenge, because here we want to, in this document, we want to highlight what are the remaining challenges to be addressed, but at least some orientation or path towards manner to address the challenge. An important point that I put at the end, of course, we need to highlight what is specific to our domain, network management and networking in general, when we are talking about a challenge. In many cases, challenges are not specific to network management in the general sense, but of course, we have some specific part in our domains that makes the challenge a bit different or to be addressed differently. Next slide, please. So what are the major updates that we have done after this meeting regarding the challenge that we have identified is that somehow we have grouped all challenges related to data under data management challenge And I was also very happy to see the presentation before, because there was some echo to what we have in this challenge. So we try to integrate the different aspects, at least that have been already provided in the document. So there are some missing elements this time probably. So with data access, data collection, sharing, how to extract knowledge or select the right feature into data. We also decide to have no IBM specific challenge. It's not really the goal of this document to have, also from the beginning of the document, we decided to have no use case specific challenge, but of course, maybe at the end we have some illustrative example of the challenge. But as we already said in all previous meetings, we want first to focus on the kind of generic challenge to avoid to be biased by a particular use case. And so, if you remember with the previous IBM specific challenge, one was more for how to plan the action once an intent is provided. So basically, we generalize that for the use of AI for planning action, not only for extracting knowledge, but really taking action into a network. And another was more about the use of, for example, NLP techniques to interpret intense or high-level representation of goals. And so we somehow integrate this and extend another channel, which was more about also integrate external events, external data source, other type of non-technical data source in general. Or at least no low-level, let's say, data to be used. Next slide, please. Okay, sorry, here basically this table summarizes what is the current progress. So basically you see in column the title of the challenge that you have. So with the list that you have, you see and then in the next column, what are the sections that have been already provided for a challenge in terms of paragraphs, and some comment from my side that I read through the document again today. So basically, when you see that it's green, basically we have already a kind of, let's say, detailed content for this challenge because we have all sections. I put the free challenge in red because they are the challenges that have been mostly talking before, that have been modified or merged or split together. And so regarding comment, so I will go more into detail for data management afterwards, but basically regarding the comments that we have still in the document, we would also have more inputs regarding anonymization techniques that could be used in case we would like to share data in our, let's say, research. Maybe there is also the question of automated network data labeling that could be probably integrated into data management. Of course, AI for planning affection, I said before that we refine the title to be not specific to IBM, but the text still need to be refined accordingly. It's not done yet. The same also for exploiting external and non-technical event. It's a kind of, let's say, and mirrored with somehow copy-paste, so it needs to be more integrated. But what is important to see in this table is that we have already 4 challenges that are quite, let's say, mature in terms of description. Of course, maybe the text may be rephrased and the format as well, but we have already a good basis for the work. Next slide, please. Okay, so the progress, maybe more focused now on the progress in the last month of on the content part, not only on the, let's say, structuring of the challenge. So for data management, as I said, so we merge multiple challenges. So it's a large coverage for this challenge with multifaceted. It's a multifaceted challenge, and we shall try to follow, let's say, the representation of the data analysis pipeline and see where there is some challenge related to data. Starting with the definition of data to be collected, the need for collection mechanisms, also the optimization for the collection of data. We've seen before regarding the aggregation, filtering, and real-time consideration. Also for customizable and flexible monitoring information, the need for label data that implies some or maybe problem regarding data sharing and utilization, but also security and privacy aspect. And we are also some in this part we have also some promises more related to how network engine can be used to support the AI by collecting data in a real-time fashion. For commercialization of AI-based product, basically correspond to where does the training occur. So it's more about how the model can be generalized and somehow it can be transferred and then commercialized. But it's more about the generalization of a model with two orientations that has been proposed: transfer learning and graph neural networks. And although we have new inputs to the explainability of network AI products, that basically is not only an issue for our domain, as I said before, we have to be specific, and here what is highlighted is that in networking, we really usually rely on procedure and algorithms with clear performance guarantees. That is very, let's say, that is in contrast with what we have with black box approach. So that's why we have a high need for more explainability. And there is also a link in this document with digital twin that is proposed in the text to use to explain the output of a machine learning model. Next slide, please. So for the next step, so we have 4 challenges that have already a wide detailed description, as I said before. The idea is that we focus on review and refining these challenges, I hope, until end of August. I know this is some of that we try to progress on this. Probably, if we can, to have a little session, maybe 1 session per challenge for people interested for the challenges, so it will be more in a small group. And also, as also well detailed description, other, let's say, challenge leader can use this description to, and of course, contributor to work on their own challenges. The idea is also to move to an idea in September in order to have the document formatted that is more common for most people in the group. So also the visibility data tracker, and proposition also is to use GitHub to work on this document for using versioning, but also to use issue tracker on GitHub to follow the discussion, because in the shared Google Doc is not so easy to follow the different commands, the different, let's say, discussion of the same command and see when they are resolved. So proposition will be to move this to this GitHub type. And yeah, that's it for myself. If you have any comment or question, please feel free to ask.
Thanks, Jérôme. I do have a question. I don't know if the answer is known yet, but so far we have been using Google Doc to let's say draft the first version of this document. There seems to be an intent to go towards an ID to put some exposure in the data tracker to the document. But have you already thought about what will be the form of the result? Do you want to have it as a publication in a magazine or a journal? Do you want to have it as an RFC? What's a bit the idea of the authors of this document in terms of publication?
So yeah, we discussed this. I didn't get so much feedback on that. So the few ideas that people are all open to the different form. Personally, but it's my personal opinion, is to go more for a magazine format in a journal. But yeah, this is only based on a few feedback that I received. But if others want to express their own opinion and that people contribute to the document, will say that I prefer for going for the options that we have to discuss with. But people have no clear preference for one or the other.
Just a follow-up question. Do you envisage that you can have different, let's say, versions or even generations of this kind of document, so that you may publish something like the first set of challenges sooner and have it maintained in a kind of RFC. I mean, not an RFC, a draft, and then continue working into a second set of challenges and then make a kind of second publication?
Yes, yeah, the challenge we identify is the first step. And yeah, of course, basically the draft will serve as will be updated regularly, I hope, and till we have a version that we are satisfied to be published. And, so either as an article in a magazine or a journal, or as an informational RFC if we decided to go for this option. But yes, the idea is that we have iterative procedure to integrate more challenges and not have something fixed.
Okay, thank you. So let's move on to our next presentation. So it will be, I think, Tanya again on network measurement intent. Let me switch to the slide.
Hello, James, can you hear me?
Yeah, I can hear you.
I'm colleague of Diane. I'm Kohan Yao. I'm from China Mobile.
Okay, thanks. The floor is yours.
Okay. Hello, everyone online. I'm Kohan from China Mobile, and I will talk about some updates to the network measurement intent draft. So next slide, please. Here is just a very brief recap of the NMR concept and the whole diagram of NMR framework. So NMR is short for network measurement intent, and it represents users or network operators' intent of the network's quality. So there are 5 major components shown in the graph. So next page, please. This time there are 2 major updates compared to the version 0.1. So the first one is we add a new use case, the clustered performance measurement intent, and this part is added by colleague Joseph Fucola from Huawei. And the second part is we add a new chapter, making classification of NMI. We divide it into static NMI and dynamic NMI. So next slide, please. This page shows the example we talked about last time. It's about the timing accuracy while choosing the right frequency to send active probing packets, or sampling rate when you do passive monitoring on network. So next slide, please. And this time, we add a new part. It's about spatial accuracy, right? So the use case, the name of use case is clustered performance measurement intent, and it's referred from RFC 8889. And it's about how to partition the network in proper ways to achieve accurate measurement result without affecting services, and at the same time reduce the resources when doing network measurement. So the spatial accuracy represents the size of the subnetworks when do partition for network monitoring. So when you're trying to partition the network, you can use a network zooming approach to either select more, to change the traffic filter policy to select more detailed flows, or to activate new measurement points by defining more specified clusters. So when a cluster after partition is experiencing performance issue, the NMI compliance assessment module will inform NMI orchestration and pre-verification modules to change, to modify the partition policy to do much better measurement. So next slide, please. And then we add a new chapter to make a classification of NMI. So static NMI intent measurement, it means that the measurement purposes remain unchanged, but and it can be translated into static value. And like here's the example, I want to filter out the links with a delay of more than 50 milliseconds. The value is unchanged when you do network measurement. And next slide, please. While on the update, we divide it into the dynamic NMI intent means the network purposes remain unchanged, but the translated policy will be adjusted according to different environments. And like I want to know that when the network busy. So and when you do some network measurement, you want to apply this intent-based system to a very large network, a very large scale network. The result will be changed based on this intent. So that's why we divide the network measurement intent into two categories. So next slide, please. And here are some next steps we think we can take after this talk. So I think we could incorporate this case to the IBM use case, and maybe we can find and we will find more concrete examples of the NMI. So that's entire talk today. Any questions?
Thanks, Lihan. Let me check the chat if I see questions. Doesn't seem so. Yeah, I think you have good development of the document. That's interesting. So I encourage you to continue in that way. And of course, if you want to consider this as in the scope of the IBM use case, that would be also, I think, very interesting to look into.
Yeah, sure. Thanks.
Let me check. No further question from the audience. So thanks, Kian, and keep in touch for the next step of this work.
Thank you. I'll mute myself.
Very well. So we've reached the end of the first set of technical presentation. We now have a status of the research group documents that will be given by Jérôme and myself as shepherd of those documents. Let me check back again. No, sorry, Jérôme, you want to start?
Yes, sure. Just wait for the slide. Thank you. Yes. So, so I'm the shepherd of the intent-based networking concept and definition Nmrg draft. So maybe just to a bit recall what has happened. So there have been the last call last year in October. So after the last call, we got generally we got positive expression support with more than 18 different sources, and in particular we got six detailed review on the draft. And so at that time, as a shepherd as well, so we already had a meeting where we discussed. We show the first bullet points that you can see here with the support and the detailed review, and we asked the author for taking into account the different review, because there are some detailed review, as I said before. And the author made a new version that has been put in the data tracker in February this year. And so, as a shepherd, I review what they have updated in the document, and so basically they address most of the comment, almost all. There is maybe one or two remaining ones that I sent to the authors. And although, sorry, before that, we agreed that my role of shepherd should evaluate if there will be a need for a new round of last call, or if the way they address the comment does not necessitate a last call. So in my opinion, basically in my opinion now, there are still some minor comments. I don't think there is really a need for again a last call on this document, because as I said before, we got a lot of positive support, and they address the different comments. This comment does not really basically modify the core of the document. So the idea now is to more address the remaining comment with directly between the authors and I, and then go for the next step, that is the submission to IRG review. And yeah, that's the status of this document. So basically, I'm now in direct contact with the author for the remaining document. Any question or feedback?
Doesn't seem we have any feedback or comments. So let's move with the next document. So it's intent classification. I am the shepherd for this document. The research group last call occurred earlier this year, from end of February to mid-March. Similarly to the other draft, the document received positive expression of support. I have not counted in detail, but it was more than thousands of either simple support to more extensive support with comments and some more information from different sources. There have been also 5, maybe a bit more, so relatively detailed reviews of the latest version of the document, knowing that the document already received quite extensive comments in the initial version. So these were the reviews received only for the research group last call period. Version 3 of the research group document was submitted in March this year, which contained a new text which addressed all the pending comments. There was quite a lot of ongoing comments, so this was a good contribution from the authors. When I was checking the draft recently, this last version, what I will put in my shepherd write-up is that of course, the authors made a very good work to progress the document according to the comments received. They have addressed all pending comments, so I think this is, let's say, addressed, solved from this point of view. I have just checked that there are some minor editorial fixes that would need to be added in order to comply with the IETF RFC series stream guidelines. So this is essentially in the abstract and introduction text to mention that it is a product of the research group, that it represents or not the consensus and the amount of reviews that the document received. But I think this is not has nothing to do with the technical content or value of the document. So this is something we could address in a future revision without major issues. So again, as Jerome said, for me on my side, I think this document is stable, has addressed all the pending comments, and is ready to progress to IRG review. Any comment or feedback on the status for this document? Olga?
Thanks. We will address those comments with on the RFC files report.
Okay, it was not easy to understand you, Olga, but I think you say that you were okay with the outcome.
Yeah, thanks. I'm okay with the outcome, and we will address the comments based on the RFC 57.
Okay, sure. It's just some details, but think this will be spotted by the IRG review, but it's minor thing we need to address. Thanks. So if there are no further feedback or comment on this point, let's continue with what we have left in the agenda. So Jérôme, maybe you want to continue with the next slide.
Yeah, just one question before we go ahead. Do you have a time frame for moving those drafts forward?
You mean to address it to you and the IRG, or in what would be the time?
Yeah, exactly. Yeah.
So I mean, we already took some time. This was a bit on Jérôme and my side to come to this conclusion. So I think now in terms of the research group status, I mean, Jérôme could confirm or not, but at least from my point of view, for these two documents, the research group has gone through the I mean, all the full process in terms of reviewing them, improving, delivering the latest version and making them stable. I don't see further needs for the research group side to work on this document. So for me, we can proceed as soon as possible, as soon as you or the IRSG will be ready to get them.
Okay, well, I mean, it sounds like if you finish up the last sort of nits on that last document and get them to me over the summer, then we'll progress them sort of, in the next month or two.
Very good. Yep. Okay. Anyway, I mentioned, excuse me, Jérôme, I mentioned to the authors that we will need for me, the next step was anyway to reach out to you, Colin, and check how we organize ourselves to provide this to the RSG, in which time frame, so that we are synchronized with the authors of these two drafts. So we will come back to you. Jérôme, I see also that Alex is trying to, is popping up sometimes, so let's see who would like to talk here.
I think this is basically what you say at the end is what I wanted to add, just that we need to synchronize the sort of fixing the last the last edits in the document. But it's, yeah, as you say, it's a minor addition, minor comments, mostly on phrasing and editorial comments. So I don't know, maybe Alex wanted to comment on the timeline.
I wanted to comment, yeah. So basically, from the author side, for the first of the drafts, certainly, I think we're pretty much ready to go. So this, hopefully, this will be days, not weeks, actually, to get it ready.
Okay, sounds good. I think we are all ready to progress. It's just a matter of being synchronized. So I think maybe just after the IETF meeting week, we can come back to this through emails and see how we make concrete steps forward.
Okay, that sounds good. Thanks.
Thank you, Colin. Thank you to the authors for this work and continuing to do this. So just moving on with the other slides of this presentation, status of the research group. Jérôme, you want to say some words for the next meetings?
Yeah, we don't have so many meetings to announce at this time, but so we will continue as usual with monthly or virtual meeting. Of course, we think we'll not have meeting next month, except if there is really need, but we have to see how we can organize in that case. But mostly, for the next virtual meeting, we already I think about two topics. One is about virtual network embedding. So if we have time, I think we will have time. We have a short presentation today, and so looks like that there is some people that are interested by this topic. It would be good to have a more dedicated virtual meeting to really understand what let's say are exactly the scope of this problem and how if and how it could fit to the Nmrg topic as well. And also there will be probably one meeting dedicated to the AI research challenges. So for the next virtual meeting in September or October, of course, there's only some possibilities. It's not totally fixed, but just to understand the topic of the next virtual meeting. And yeah, we hope to have the next one of the next meeting face to face, but we'll see maybe in November in Madrid. And as usual, yes, if you have a new topic that you want to propose, please let us know. We'll see how we can arrange that in one of our next meetings. Not more from my side, Laurent. I don't know if you want to add something.
No, I don't think we have much news for the research group status beyond the document and the future meetings. Let's take the time maybe to give the floor to the other research group participants that are proposing work on network, related to network embedding. So just to situate a bit, before this meeting, there have been a couple of new drafts submitted in the context of the Nmrg, and both were addressing virtual network function embedding problems from different angles, let's say. So we discussed with Jérôme about the agenda of this meeting for this session, and we didn't want to put too many topics. So that's why we suggested to the authors of this draft to dedicate an interim meeting to explore these proposals. Because to our knowledge, virtual network embedding is a very interesting problem and has been quite explored in the last 10 years. Especially, there is a lot of literature and existing solutions onto that. So we wanted to understand better what would be the research scopes, the research questions or challenges that still exist today, or if there are new contexts that triggers this work. And we thought that having enough time to address that in a dedicated interim meeting will be the best way forward, instead of rushing that in this session. But still, as we have a bit more than 10 minutes left, we wanted to give the floor to these two draft authors to make a kind of pitch of their work. But this will be only a teaser for the upcoming interim meeting. So Pedro, you will have the floor for the first draft. Let me bring up the slides. Jérôme, do you think we have slides?
Can you see my screen?
I think
Not
Pedro
yet.
wants to share the screen, but yeah, Pedro, I think then if you can also send the slides that we can put on the data tracker.
It's okay. I gave Pedro the floor, so you should see his screen now. Pedro, you're sharing your screen, but we don't see the slides.
I'm sorry, wait, please second, because this is something like. Okay, now.
Good, we see that.
Okay. Well, I will be quite fast. This is just a very brief summary of what I am trying to achieve with this presentation. And first, I would like to answer the concern that Laurent has just put in the table. That is that why now is a moment for virtual network embedding, and the key is that although different methods for embedding have been already been explored in the past, there are new scenarios, new let's say scales that are not properly addressed. Like, for example, virtual networks have a real lot of elements that must be addressed, and new workloads that, for example, as I can see here, please, new works like this one. There is, for example, as you can see on the left, we have a lot of virtual network functions that we want to instantiate in some physical nodes. But what we have now is to optimize the embedding dynamically. So as you can see here, we tried not to move the nodes that have been already well placed, and just move the nodes that must be moved. Okay, the current state of the art is mostly based on linear programming, so they are hardly able to manage the size of virtual network and physical network that we are talking today. So we need new approaches to resolve them. So what precisely I am proposing is to somehow define one genetic approach to resolve that, and one, let's say, abstract genetic approach. As you can see here on the right, what I am proposing is a very simple genetic algorithm, but we have different ways of creating new configurations that are respecting the previous configuration if needed. This algorithm is begins with an empty configuration, but it can begin with the current configuration of the network. So we are concentrating in evolving it, and genetic algorithms are best for evolution. So that's what why we are proposing them, and that must be more or less somehow managed in terms of some agreement of the procedure, because otherwise they can give some disparate results and the quality is not as good as required. So in summary, there are new circumstances, new scenarios that are not well covered by current or previous approaches for network embedding. And also there are new approaches like genetic algorithms that are giving better results than previous approaches. So when we put both together, that justify that currently, today is there are some needs for this work inside the IETF, especially in the Nmrg. I mean, this research aspect of the network. We must research this kind of algorithms. We must research, for example, as I can reference this, of what kind of mutation, breeding, or creation of configurations we can do in order to improve the resulting configuration of the network. That's my summary. I hope this gives some kind of illustrative or illustration of what are my intentions. I will just finish so other can talk. Thank you.
Thank you, Pedro. Please check the chat. Philip is asking if you could share the slides. I don't think we have uploaded them on the data tracker yet. We were not sure to have this.
I will share them. I will share them. Okay.
And I'd like to give the floor to Isan.
I will
So
stop
Isan,
sharing now.
if you're here, let me check. Yeah. Isan, I don't know if you have slides you want to share, but you need to ask for sharing your screen. Ersan, can you hear us? You still have the possibility to present, or at least not necessarily present slide, but if you want to talk about your proposal, the floor is yours. You can put you in the queue or ask to share your screen. Ersan, can you hear us? Do you need assistance in trying to? Okay. Ersan seems to be off now. Let's give him some seconds to see if he reconnects or try to participate actively in the meeting. So while Isan is trying to reconnect, maybe there is another draft. You can see it in the agenda, at the end of the agenda. It's another draft that is proposing to use a reinforcement learning approach for the virtual network embedding problem. So this is why we suggested to group these two drafts together in an inter-meeting and see what could be the research questions to address. Let me see. I don't see Ilan again. Let's give him a minute. In the meantime, just to fill in, if anybody has comments either on this topic or anything for the Nmrg, please raise your hand or speak. Okay, I don't see Hirsen coming back. Just so we will address on the mailing list a doodle to find a good slot for this inter-meeting dedicated to VNE, and hopefully we can have inputs from these two drafts. Our idea was also to prepare a bit offline, as we said, about trying to understand the new context for bringing VNE into the scope of Nmrg, to understand what will be the research directions supported by these proposals. So I don't see Hirsen coming back. Jérôme, do you have anything else to add?
No, nothing from my side, Laurent. So it's okay. Just to thank all the participants for this meeting.
Yep. Okay. Thank you everyone for attending. Let me check one final in the participant list. I don't see Hirsen coming back, so we will reach out to him and involve him in the preparation of the upcoming inter-meeting. Thanks to everyone. Thanks to the presenters. Thanks to the authors for this document. Have a good rest of the day, if it's still day for you, or a good night for the ones that stay up late. Thank you, everyone. Goodbye.
Thank you all. Thank you, Laurent. Bye.